In this lesson, we're going to learn how to solve an absolute value inequality. And the absolute value inequalities that we're going to look at in this lesson are going to be of this form. So it'll be an absolute value of an expression with the variable x is going to be less than or equal to some positive number. So this number on the outside will be positive. Okay, so we're going to look at the parts where this is positive. Okay, now let's kind of review something about the absolute value equation. So we talked previously about absolute value equations. So let's look at an easy one. So if I have the absolute value of x is equal to 3, intuitively, by inspection, you could tell me what the solution is. So the absolute value of what number is 3? Well, remember in the previous lesson, you saw that the absolute value of a number of this number right here is 3 units from 0. So when I go to the right 3 units and when I go to the left 3 units, I get 3 and negative 3. So 3 units to the right, 3 units to the left, because this is 3. So we saw that the solution would be x equal 3, and the other one is negative 3. All right. Then we looked into something like this. All right. If you have, let's say, x plus 5 is equal to 2, same idea. So you're going to break it apart to where we would say the absolute value of x plus 2 is equal to 5, and then we would write it as two linear equations. In this case, you would say x plus 5 is equal to 2, and then x plus 5 is equal to negative 2. And then you would solve these linear equations. So we subtract 5 from both sides. One of your solutions is negative 3. And over here, subtract 5 from each side, and you get the other solution to be negative 7. All right? So when x is negative 3, and you can always check, when x is negative 3, this equation is going to be a true statement. So let's check just negative 3. So negative 3 plus 5 is 2. The absolute value of 2 is 2. And if you do this with negative 7 plus 5 is a negative 2. The absolute value of a negative 2 is a positive 2. Okay? What I want you to notice from these two, though, is that with these absolute value equations in both of these, how many solutions did you have? You had exactly 2 solutions in both cases. So you had a finite number of solutions. Okay? But what I want to look at, though, is this. Okay, what if instead of having the absolute value of x equal 3, what if I had this? What if I had the absolute value of x is less than 3 instead? All right, so let's think about the solutions. What are some solutions can you think of that would work here? All right, so just think of some solutions. Let's look at this in terms of a number line. All right, so I'm going to put some numbers here. So let's start with 0. Is 0 a solution to this inequality? All right, so let's see. The absolute value of 0 is 0, and 0 is less than 3. So the answer is yes. I'm going to put a closed circle here to indicate the solution, that's a solution. And I'm going to use integers for right now. So if x is, let's say, 1, is 1 a solution to this inequality? Well, the absolute value of 1 is 1, and 1 is less than 3, so it sure is. In fact, if you look at the numbers between 0 and 1, let's say 1/2. Is 1/2 a solution to this inequality? Well, what's the absolute value of 1/2? 1/2, and 1/2 is less than 3, so that is. In fact, I'm going to shade in all these real numbers here because those are solutions. All right, let's continue on. Let's look at 2. Is 2 a solution? And let's check. What's the absolute value of 2? Well, the absolute value of 2 is 2, and 2 is less than 3. So that is a solution. What about every number between 1 and 2? Like 1.5, 1 and 1/2. Is that a solution? Yes, it is. What's the absolute value of 1.5? 1.5, and is 1.5 less than 3? It sure is. So in fact, every number here is a solution. So far I have this. I have that so far I've figured out that some of my solutions are between 0 and 2. Every real number between 0 and 2, and including 0 and 2. All right, let's go to 3. Is 3 a solution? All right, is 3 a solution? Now be careful. Is 3 a solution? I'm going to go ahead and kind of write it on here. So the question is 3 x equal 3 a solution? 2, the absolute value of x is less than 3. So if I substitute 3 in here, look at what I get. The absolute value of 3 is less than 3. And what's the absolute value of 3? The absolute value of 3 is 3. Now the question is 3 less than 3? That's the question. Is 3 less than 3? The answer is no, right? The answer is no. 3 equals 3. 3 is not less than 3. So the answer is no there, right? So I'm going to come back. So that means that this is not a solution. So that's not a solution. All right, so I'm going to come back, and on 3, I'm going to put an open circle. So the open circle to indicate it's not a solution. But what about a number between those, between 2 and 3? Let's say 2.5. Is 2.5 a solution? Well, what's the absolute value of 2.5? The absolute value of 2.5 is 2.5, and 2.5 is less than 3, so it sure is. In fact, it's any real number up to 3. So for example, I'm gonna see I put up to 3, right? So the question is x equal 2.9999 a solution to the absolute value of x is less than 3? Is it? If I substitute this into here, what do we get? The absolute value of 2.9999, and you're asking is that less than 3? What's the absolute value of 2.9999? What's 2.9999? And is that a true statement? The answer is yes. So that's a solution. Okay? All right. So let's go to the so right now I found this that any number, I hope you see this, that any number greater than 3 is not a solution. For example, 4. Is 4 a solution? What's the absolute value of 4? The absolute value of 4 is 4, and 4 is not less than 3. So you stop there. Don't do anything else on this side. Don't do anything else on this side. Okay? Now let's go to -1. -1. Is -1 a solution? What's the absolute value of -1? Well, the absolute value of -1 is 1. And is 1 less than 3? The answer is yes. So I'll put a closed circle there. And anything between those is also a solution. -1/2. Absolute value of -1/2 is 1/2. 1/2 is less than 3. What about -2? Is -2 a solution? The answer is yes. The absolute value of -2 is 2, and 2 is less than 3. So any number between -2 and -1 is a solution. So far I know all of this. All these are solutions right here, up to 3. And what about -3? All right, I'm going to write this down just to make sure you understand this. So I'm going to put this here. Is x equal -3 a solution to the absolute value of x is less than 3? So in place of x, I'm going to substitute -3. So the absolute value of -3, is that less than 3? Well, what's the absolute value of -3? The absolute value of -3 is a positive 3. And is that less than 3? Is 3 less than 3? The answer is no, it's not. 3 equals 3, right? Just like this statement here. And so this is not a solution. All right, so right away I'm going to put that in open circle. Put this in open circle. And then if you notice, if you pick a number between -3 and -2, let's say -2.5, the absolute value of -2.5 is a positive 2.5, and 2.5 is less than 3. So all these are solutions. And if you look at -4, just like we did 4, if you look at -4, the absolute value of -4 is 4. 4 is not less than 3. So what I found is this, and I want you to notice this. What I found is this. The solutions to this inequality is any number between -3 and +3. The solutions to this absolute value less than inequality is any number between -3 and +3. So I'm gonna write this solution. So here's the graph right here. So here's the graph. -3, +3, open circles. And by the way, they're open circles because there's no equal sign. If there was an equal sign, we would put closed circles here. And I'm going to shade in everything between them. All right. As an inequality, my solutions would be any real number between 3 and -3. All right. So Notice the solutions to this absolute value less than inequality can be written as this compound statement right here. This compound statement. Okay? All right, now, remember a while ago when we did the absolute value? See this number right here and this number here? We'll put 3, negative 3 here, 2, negative 2, right? Okay, when I come here, what do you see? 3, you have negative 3, 3, right? Okay, so let's go further with this. So before I go on, let me just say this. Whenever you have an absolute value less than inequality, whenever you have an absolute value less than inequality, you can write it as this compound statement. Notice what's inside the absolute value bars is in the middle, and then the numbers on the outsides are the opposites, or is the opposite of this, and then the same as this. Okay, so these numbers are opposite of each other, and it comes from this number right here. Okay, so it's very simple. Don't let what we just did confuse you. It is a very simple process. Whenever you have, remember we're dealing with absolute value less than, it is very simple to do. So let's look at this example. So these are going to be examples we're going to look at. So we're going to solve each absolute value inequality. Okay? All right, so number 1. Let's suppose we had the absolute value of x plus 5 is less than or equal to 7. The absolute value of x plus 5 is less than or equal to 7. Okay. Now we're dealing with an absolute value less than inequality. In this case, it's less than or equal to. Whenever you're trying to solve an absolute value inequality, and for some students, it's not intuitively easy for them to understand this. What I would do is I would think of a simple example just like this. And in your mind, you're asking yourself, the absolute value of what numbers is less than 3? Well, it will be anything less than 3 and anything greater than negative 3. And so you know that you're going to say, well, x has to be between 3 and negative 3. So what's inside the absolute value bars has to be between negative 3 and 3, right? So if I do the same thing here, what is inside the absolute value bars? Well, what's inside the absolute value bars is x plus 5. So therefore, x plus 5 must be less than or equal to 7. And at the same time, it must be greater than or equal to negative 7. So I want you to compare this. Okay, look. Compare this. See this right here? This. Okay? And then this. See it? So this middle part here comes from this middle part. What's inside the absolute value bars? Okay? This middle part here came from what's inside the absolute value bars. So whenever you have an absolute value less than inequality, you want to write it like this. You want to write a compound statement. All right? And then now you've had this before. How do you solve this compound inequality? That was one of your previous lessons. So you're going to get the variable in the middle by itself, right? So you're going to subtract 5 from both sides. And then combine like terms, a negative 7 and negative 5 is a negative 12. It's less than or equal to x. It's less than or equal to, and then 7 subtract 5 is 2. And those are your solutions. So every real number between negative 12 and 2, including negative 12 and including 2 because of the equal sign, will be a solution to this inequality. All right. So just out of curiosity, is the number 8? So I'm going to ask you this. Number 1 is x equal 8. Is x? Let me write this better. Is x equal 8 a solution to this inequality? A solution to the absolute value of x plus 5 is less than or equal to 7. It's not in here, right? So 8's not in here, so you better say what? You better say no. So let's see why. If I substitute 8 in here, I get the absolute value of 8 plus 5, and I want to see if that's equal to less than or equal to 7. Well, 8 plus 5 is 12. And what's the absolute value of 12? Well, the absolute value of 12 is 12, and is 12 less than or equal to 7? And the answer is no. So that's why you don't see it in here. But any number, any real number, decimals, fractions, rational numbers, irrational numbers that's in here will be a solution. Okay? Now they're going to ask you to write this in interval notation. So interval notation, remember, whenever you see a equal sign, you can use bracket. So you can say bracket -12, comma, 2 bracket. So that's your interval notation. Okay? Interval notation. If they ask you to graph it, just make sure on -12 right here, you have a bracket. So make sure it looks like a bracket though, okay, not a parentheses. And on 2, you have a bracket as well. Okay, and then shade in. Make sure you shade in everything between them. All right, so that's how you're going to solve an absolute value less than. Whenever you have an absolute value less than, you're going to write it as this compound statement. So you're going to write as a compound statement. Okay, compound inequality. Compound inequality. All right, so let me write the word inequality instead. Inequality. All right, so let's do number 2. So don't. It's not that difficult. Not that difficult at all. So in number 2, let's suppose we had the absolute value of 2x minus 1 is less than 5. So it's an absolute value less than. Always look to see what kind of inequality symbol you have. Absolute value less than. If it's an absolute value less than, you want to write as a compound statement. Okay, so basically what's going to happen is this. Let me do it this way. So whenever you have an absolute value less than inequality, you're going to write as a compound statement. So you're going to say ax plus b is less than c, and at the same time, ax plus b has to be greater than a negative c. It's going to look like this. Okay, negative c, c, and this goes in the middle. Okay, that's how you're going to always do it. So when I do this, you're going to say, oops, I didn't mean to do that. You're going to say 2x minus 1 is less than 5, and at the same time, it has to be greater than what? Negative 5, right? All right, so 2x minus 1 is less than 5, and at the same time, it has to be greater than negative 5. And then all you do now is just get the variable x in the middle, so we're going to add 1 to all parts. So negative 5 plus 1 is a negative 4, is less than 2x, is less than 6. And then finally, you're going to divide both sides by 2, and negative 4 divided by 2 is a negative 2, is less than x, is less than 3. So the solutions to this inequality, the numbers for x that will make this side less than 5 will be any real number between negative 2 and 3. Okay? So in interval notation, no equal sign, so you're going to be parentheses. So you're going to say negative, in parentheses, negative 2, then to 3, parentheses. If you were asked to graph, you make sure you put it in order. Negative 2 is less than 3. That has to be in order. And you put parentheses, and just make sure it looks like parentheses. Okay? Just like that. Negative 2, 3, and then shade in every number between them. And that's all that is. It's not that difficult at all. Okay? Let's look at number 3. So let's do another one like that. So let's suppose we had the absolute value of 3x plus 2 is less than or equal to 4. So again, notice I have an absolute value less than. Whenever you have an absolute value less than, you want to write it as a compound inequality. That statement where you have two inequality symbols in that same statement. So that's an absolute value less than. In this case, it's less than or equal to. So we're going to say this, what's inside the absolute value bars, which is 3x plus 2, has to be less than or equal to 4. All right, so you're going to rewrite, just think about this. You're rewriting this without the absolute value bars. But remember, you got to write as a compound statement, okay, because it's absolute value. And then you're going to say, well, that's going to be also greater than or equal to, and then the opposite of that, which is negative 4. And then all you do now is to get the variable x by itself. So we're going to subtract 2 from all parts. negative 4 to negative 2 is a negative 6. It's less than 3x, less than or equal to 3x. It's less than or equal to 2. And then divide all parts by 3. Divide all parts by 3. And then reduce if you can. Negative 6 divided by 3 is a negative 2. It's less than x, less than or equal to x, and it's less than or equal to 2/3. Okay? All right, so there's your solution. So my solution to this inequality will be any real number that's between negative 2 and 2/3, including negative 2 and including 2/3. All right, so notice that zero's in here, right? So I just want to check it. So let's just, now first of all, how many solutions are there? They're an infinite number, right? They're an infinite number. There's no way you can list those. They're an infinite number. So when we did the absolute value equations as a review earlier, right here, there were 2 solutions. That's a finite number. Finite meaning you can count 1, 2. Here, there are an infinite number of solutions. There's no way you can tell me how many solutions there are. Don't think your solutions just those integers. We talked about that. You have any real number that's shaded. All these numbers between negative 3 and 3 are solutions. The decimals, the fractions, any rational number, any irrational number. So there's an infinite there. All right. So I asked you earlier. I said, is zeros in here? So let's see why zeros in here. So is x equals 0 a solution? So is x equals 0 a solution to this inequality? All right, let's see. So in place of x, I'm going to substitute 0. So I get 3 times 0 plus 2. And I want to see if that's going to equal, if that's going to be less than or equal to 4. 3 times 0 is 0. And is 0, and the absolute value is 0 plus 2. 0 plus 2 is 2. The absolute value of 2 is 2. And the question is 2 less than or equal to 4? And the answer is yes. So that's why 0 is a solution. Okay? 2/3 is a solution, right? So let's see why 2/3 is a solution. So is x equal 2/3 a solution to this absolute value inequality? So in place of x, I'm going to substitute 2/3. So I get the absolute value of 3 times 2/3 plus 2. And I want to see if that's going to be less than or equal to 4. Well, 3 times 2/3, so 3's divide out. So 1 times 2 is 2, so that's 2. So we have the absolute value of 2 plus 2. 2 plus 2 is 4, so that's the absolute value of 4. And the absolute value of 4 is 4, and is 4 less than or equal to 4? It's 4 less than or equal to 4? Yes, it is. It's equal to, right? So the answer is yes. So x equal 2/3 is a solution. So that's why you see an equal sign here. Now 3 is not in here. So let's see why 3 is not a solution. So is x equal 3 a solution? Is x equal 3 a solution to this absolute value inequality? We know it's not. We know it's not because it's not in this interval. It's not between negative 2 and 2/3. So we're going to substitute x equal 3 here. So we have 3 times the absolute value of 3 times 3 plus 2. And I want to see if that's going to be less than or equal to 4. 3 times 3 is 9. So that's the absolute value of 9 plus 2. 9 plus 2 is 11. And the absolute value of 11 is 11. And is 11 less than or equal to 4? And the answer is no. Okay? So that's not a solution. So the answer is not a solution. All right, so the only solutions are going to be between negative 2 and 2/3. So the solutions for x will be any real number between negative 2 and 2/3. In interval notation, you're going to say bracket negative 2, comma, 2/3 bracket. Okay? So any real number here. If you were to graph this, and let's say on the graph you had this, 1 and then 2. So you'd put a closed circle on negative 2 because of the bracket, because of the equal sign, and then you estimate where 2/3 is. So 2/3 is between 0 and 1, but it's closer to 1, right? So let's put the closed circle here. So this is going to represent 2/3, closed circle. And so we shade in everything between them. Okay? All right, so that's number 3. Not difficult at all. Fairly simple process. All right? Now let's look at this one. Now, you have to be careful. You have to be careful when you have the problem looking like what I'm about to write. We have 3 times the absolute value of x plus 1 is less than 9. All right, now remember we talked about the fact when we talked about the absolute value equations, don't confuse absolute value bars with parentheses and then you think about, well, I can distribute here. You got to be careful. If this number is positive on the outside of the absolute value bars, then yes, you could distribute, okay? But that only applies if it's positive. So if it's negative, you cannot do that. You cannot distribute if this is negative, because this is not parentheses, this is absolute value bars. So in one of the previous lessons, we looked at that fact. So to be on the safe side, whenever you have a number on the outside, whether it is positive or whether it is negative, what you want to do is get the absolute value expression by itself. So right now, I'm multiplying by 3. Let me go ahead and rewrite this over. All right, so I'm multiplying by 3. The opposite of multiplying by 3 is to divide both sides by 3. So 3 divided by 3 is 1, 3 divided by 3 is 1. So I get the absolute value of x plus 1, which is what this is now, is less than, and the 9 divided by 3 is 3. So now this right here now looks like this, right? Okay? So remember this. If you have a number on the outside of the absolute value bar, multiplication 3 times, whatever, if this number is positive or negative, to be on the safe side, always do this first. Always divide both sides by this number. Okay? If you distribute and you're not careful, you're going to end up making a very incorrect mathematical statement. All right? So you got to be careful. If it's positive and you distribute, you're okay. But if it's negative and you distribute, you are not okay. This is no longer a valid mathematical statement. Those two statements that you write are not going to be the same. Okay? All right, so always get the absolute value expression by itself first. So you can divide both sides by 3 in this case. Okay? And now you're going to, since this is an absolute value less than, you're going to write as a compound statement. So you're going to say x plus 1 is less than 3. And at the same time, it has to be greater than what? The opposite, negative 3. And then you just get x by itself, and you're done. So you're going to subtract 1 from both sides, from all parts. Negative 3 and negative 1 is a negative 4. It's less than x. It's less than, and 3 minus 1 is 2. So the solutions to this original inequality is any real number between negative 4 and 2. Notice there's no equal sign, so negative 4 is not a solution, and 2 is not a solution either, but any number between them. Okay? All right? So the as an inequality, interval notation, the solution will be parentheses negative 4, comma, all the way to 2 parentheses. And then the graph, if this is negative 4 and this is 2, you're going to have open circles on those two numbers. All right? And shading everything between them. Okay? All right. Now, I want to make sure you understand why we put an open circle here, because remember, there's no equal sign, so x cannot be negative 4. My solution cannot be negative 4. Make sure you understand why. So if you check this, x equal negative 4, if you ask yourself, is x equal negative 4 a solution to 3 times the absolute value of x plus 1 is less than 9? Let's see. So in place of x, you're going to substitute negative 4. So I get 3 times negative 4 plus 1. And I want to see if that's going to be less than 9. Well, negative 4 plus 1 is negative 3. So I have 3 times the absolute value of negative 3. And I want to see if that's going to be less than 9. Well, the absolute value of negative 3 is 3, right? And 3 times 3 is 9. So the question is 9 less than 9? The answer is no. 9 is not less than 9. 9 equals 9. Okay? So that's why that's why you see at negative 4 an open circle, because it's not a solution. But any number between negative 4 and 2 is, and any number on the outside of those of negative 4 and 2 is not a solution. All right? Okay, so remember what we just said. Whenever you have an absolute value inequality and you have a number other than 1 here, see the coefficient here is 3. And number 3, there was no number there, but that's understood to be a 1. Okay? All right. So if you see a number out there other than 1, you want to do this first. You must do this first. If you don't, and you're not careful, you're going to, and this is negative, and you distribute, what you have is incorrect. Mathematically incorrect. Okay, so let's look at number 5 now. Okay, based on what we just talked about, let's see what you're going to do with number 5. So here's number 5. So number 5, we have negative 2 times the absolute value of 2x minus 3 is greater than or equal to negative 8. All right? So that's what we have. Now, some of you are going to say, well, you said that this lesson is only going to have less than inequalities. And now you have a problem that's a greater than. Well, hold on. Let's go through the process first, and you'll see what's going to happen. So based on our discussion with number 4, I have a number out here, right? So the process is to go ahead, since I'm multiplying the absolute value expression by 3, we're going to divide by 3, okay? Over here, what I'm multiplying the absolute value expression by? I'm multiplying by negative 2. We're going to write this over. And so then, using that same idea, I'm going to divide both sides by negative 2. But what I do to one side, you do to the other, right? Okay, now let's see if you remember something. Remember in a few lessons ago, whenever you multiply or divide an inequality by a negative number, what must you do to this inequality symbol? You must reverse it. Okay? So remember, whenever you divide or multiply both sides of an inequality by a negative number, reverse the inequality symbol. Okay? All right, so now the negative 2's divide out. So now here's what we have. This is the one right here. We have the absolute value of 2x minus 3. Reverse this. Greater than or less than becomes less than or equal to. And then negative 8 divided by negative 2 is a positive 4. Okay? And so therefore, I can now see that I now have an absolute value less than inequality. All right? So notice there are going to be some solutions because look, the absolute value of this expression is either 0 or positive, right? The absolute value of a number is positive or 0. So are there positive numbers that are less than or equal to 4? The answer is yes. All right, so we got to figure out what values of x will make this less than 4 or equal to 4. That's our question. All right. Now you may say, well, how are these two the same? Those are equivalent, by the way. This is equivalent to this. All right, because I did the process correctly. I divided both sides by negative 2 and a reverse inequality symbol. So the solutions to this will be the solutions to this. And so when we find the solutions, I'll go back and I'll show you that what we get here will be the solutions to this. All right. So less than, absolute value less than, so we know what to do. 2x minus 3 is less than or equal to 4, and at the same time has to be greater than or equal to a negative 4, right? And then you just get x by itself. So we're going to add 3 to both sides, to all parts rather. Negative 4 plus 3 is a negative 1. Is less than 2x. Is less than or equal to 7. Then divide all parts by 2. I get negative 1/2. Is less than or equal to x. Is less than or equal to 7/2. So my solutions are going to be any real number between negative 1/2 and 7/2. Okay? So I found the solutions. So all these real numbers, and there are an infinite number of them. All these decimals that are in here, all these fractions that are in here, all these irrational numbers, rational numbers. So all those are solutions. So there's an infinite number. And so in interval notation, you're going to say bracket negative 1/2 all the way to 7/2 bracket. Okay? And then as a graph, if you were asked to graph this on the number line, let's say this is negative 1, this is 0, this is 1, 2, and let's say this is 3. So negative 1/2 is here. So we put a closed circle here to indicate negative 1/2. And then 7/2 is 3.5. Yes, 3.5. So you go to 4 here. So 3.5 is here, closed circle, 3.5. And then you shade in everything between them. Okay, so those are all the solutions. All these solutions are being shaded. All these real numbers are being shaded is a solution. Is a solution to this, and it's also a solution to this. Okay, so what I want to do though is I'm going to ask you again. I'm going to say, so first of all, you can see here that 2 is a solution, right? 2 is a solution. It's shaded. So let's see why. So is x equal to a solution to the original equation, to the original inequality? A solution to negative 2 times absolute value 2x minus 3 greater than or equal to negative 8. So let's see if that's a solution. So in place of x, I'm going to substitute 2. So I get negative 2 times the absolute value of 2 times 2 minus 3. And I want to see if that's going to be greater than or equal to negative 8. Okay, let's do what's inside the absolute value bars. 2 times 2 is 4, and 4 minus 3 is 1, right? 4 minus 3. That's going to be 1. So I have negative 2 times the absolute value of 1, and I want to see if that's going to be greater than or equal to a negative 8. Well, negative 2 times, well, absolute value of 1 is 1. So negative 2 times 1 is a negative 2. And the question is a negative 2 greater than or equal to negative 8? And the answer is yes, right? On the number line, if you think about it, here's negative 8, here's negative 2. Any number to the right of a number, that number is greater, okay? So that's why 2 is a solution to this. If you check it, it makes the left-hand side greater than or equal to a negative 8. All right? Okay, so that was number 5. Now let's do one more with a negative number on the outside. All right, so process. Remember the process. So this is going to be number 6. So number 6, we have, okay, number 6, we have the absolute value of, negative 3 times the absolute value of x plus 7 is greater than or equal to negative 12. All right, now be careful because the way you solve an absolute value less than is not the same, the process is not the same you would if this were greater than, so you got to be careful. All right, so you see a greater than or equal to here, right? But remember, you want to get rid of this negative 3 first. You want to isolate this absolute value bar. So right now, I'm multiplying by negative 3. Let me go ahead and write this over. Multiply by negative 3. So the opposite is to divide both sides by negative 3. But remember our statement earlier. Whenever you divide or multiply both sides of an inequality by a negative number, you must reverse the inequality symbol. So here, I divided both sides of this inequality by a negative number. So I'm going to have to reverse this inequality symbol. So negative 3 divided by negative 3 is 1. So notice I have 1s here. And 1 times the absolute value of x plus 7 is the absolute value of x plus 7. Is now, reverse it now, greater than or equal to becomes less than or equal to. And then negative 3 divided by negative 12 divided by negative 3 is a positive 4. All right? And so now I have an absolute value less than, and I know that when I have an absolute value less than, I write as a compound statement. Write as a compound inequality. That's how you're going to do that with absolute value less than. So I get x, what's inside the absolute value bars? I get x plus 7 is less than or equal to 4. And at the same time, it has to be greater than or equal to a negative 4. And then all you do is get x by itself. So subtract 7 from all parts, and you have your solutions. The solution to this original inequality will be any number between, let's see, negative 7 and 4 is negative 11. Is less than or equal to x. Is less than or equal to, and then 4 subtract negative 7. 4 subtract 7 is a negative 3. So any real number between negative 11 and negative 3 is a solution to this, and it's also a solution to this. Okay, so these are equivalent. All these statements here are equivalent. So this, and all these are equivalent. So the solutions to this is the solutions to this, is the solutions to this, is the solutions to this, is the solutions to this. Okay? So in interval notation, you have equal signs, you use brackets. So bracket negative 11, comma, negative 3, bracket. So any real number here, there are an infinite number of solutions. And then if you were asked to graph it, here's negative 11, here's negative 3, and on negative 11, you're going to use closed circle, negative 3 closed circle because of the equal sign or the brackets, and you're going to shade in every number between them. All right? And that's it. That's how you solve, that's how you're going to solve an absolute value less than inequality with this number here being positive. Okay? Okay, so that is the end of this lesson. Now, in the next, either the next one or the next one after that, we're going to look at greater than absolute value inequality that has a greater than symbol. We're going to see what to do. Well, what if it says greater than? Everyone we've done, before we broke it apart like this, before we wrote the compound inequality, it turned out to be a less than, absolute value less than. In the next lesson, or the lesson after that rather, it's going to be greater than. Okay? All right, so that's the end of this lesson.